All right, let's talk about green fuel. We hear all the time that it's the future, but what's the real price tag? Today, we're doing a deep dive into the actual economics of advanced biofuels to find out what's really going on.
I mean, this is the big question, right? It's the one thing that hangs over the entire industry. Biofuels have all these amazing environmental benefits, but they just can't seem to win on price. So what's the deal?
To get to the bottom of this, we're not just guessing. We're turning to a true expert, Dr. Mahmoud Karimi. He's an assistant professor of biosystems engineering, and get this, he's recognized by Stanford University as a top 2% global scientist. This is his specialty, the hard economics of sustainable energy.
And the key to this whole puzzle is his massive review, published in Energy Conversion and Management X. This thing pulls together decades of research to figure out, once and for all, what really drives the cost of making green fuel. Okay, let's get into it. So first, let's really frame the problem here, this big puzzle that has so many people stumped. This quote from the paper just nails the paradox perfectly. We've got this incredible technology that could slash emissions, but the whole industry just feels like it's stuck in first gear. And the paper argues the reason is pretty simple. It all comes down to money. To really crack this economic puzzle, we gotta speak the language. So let's break down two crucial terms that are gonna guide us through this whole analysis. First up is something called a techno-economic analysis, or TEA. Honestly, the best way to think of this is like a super detailed business plan for a biofuel factory. Before you spend billions on a new plant, a TEA runs all the numbers to see if the thing can actually turn a profit.
And that analysis spits out our most important number, the minimum product selling price, or MPSP. This is the break-even point, the absolute rock-bottom price you have to sell your fuel for per gallon just to cover your costs. If you can't hit this number, you're toast. It is the ultimate test.
So what actually goes into that price? Well, when you slice it up, one thing just jumps right out at you. The single biggest chunk of the cost, a whopping 35%, is the feedstock. That's the raw material you start with. You know, the wood chips, the algae, whatever. Now remember that number. It's going to be a huge deal in a minute. And the paper's analysis pretty much confirms this. It's like a balancing act. The things that drive the price up are the tech you choose, the cost to build the plant, the cost to run it, and, yeah, that big one, the cost of feedstock. And the two things that can bring the price down, getting more fuel out of your material, that's conversion yield, and just being more energy efficient. Okay, so we've got the tools. Now it's time to put these leading technologies to the test, put them head to head, and see how they stack up. The study really zeroes in on 6 major contenders in the advanced biofuel game. You've got everything from making ethanol out of wood, which is ETHO, all the way to converting fats into jet fuel known as HEFA. Each one has its own process, its own advantages. So the race is on. Which one is the cheapest? And here are the results. The moment of truth. On the most expensive end of the scale, you have alcohol to jet, or ATJ, at nearly $6 a gallon. As you move down the line, the prices get a little better. But wow, one of these pathways has a serious advantage over the rest. And the winner, by a long shot, is hydrothermal liquefaction, HTL for short, coming in at just $4 a gallon. That is a huge, huge lead on its competitors. So why? Why is it so much cheaper? Well, remember what I told you to remember? The feedstock cost? It all comes back to that. For a pathway like HEFA, which uses pricey oils, the feedstock makes up a staggering 2/3 of the final cost. But HTL? It can use cheap, wet waste. Think sewage sludge. So for HTL, the feedstock is only 19% of the cost. That is the secret sauce. So, case closed, right? HTL wins. Well, not so fast. The final part of the paper reveals a really surprising twist, and it points to where the real future of this industry is headed. You'd assume that after 20 years of incredible technological progress, the price would go down. I mean, that just makes sense, right? Wrong. The analysis found that over the last 2 decades, the projected break-even price for these biofuels has actually gone up. How on earth is that possible? The authors offer a fascinating explanation. They argue that the economic models themselves are lagging behind the science. They're failing to account for innovations that squeeze more fuel out of the same material, and, this is the big one, they totally ignore the value of byproducts. They're basically treating treasure like it's trash. So the paper's big solution is actually pretty elegant. It's simple. Stop throwing things away. Instead of just making your bio-oil and calling it a day,
A modern facility should valorize, or find value in, every single byproduct. The nutrient-rich water can be used to grow more algae. The leftover solids can become biochar for soil. You create this beautiful circular system where absolutely nothing is wasted.
And that brings us to the final verdict, the big takeaway from this whole analysis. The most promising path forward is a one-two punch. Combine the most cost-effective technology, that's HTL, with a really smart circular strategy that turns every single byproduct into another source of value.
So, in the end, the paper leaves us with this really powerful thought. The high price of biofuels isn't just a technology problem, it's a design problem, a problem of imagination. The path to making green fuel affordable isn't just about inventing new gadgets, it's about completely rethinking what we consider to be waste.